What's our definition here? I thought you were ready. It's alright. It's alright. It's alright. Does it say the word with?
Yes. There
Okay. Inputs and outputs. What did it
are
say?
No, it says
I can read.
it says pairs inputs and outputs. The way y'all put it is pairs.
It makes no sense.
It's pairs inputs with outputs. Pairs inputs with outputs. It didn't make sense. No, the way you said it.
Pairs, inputs, and outputs. I like it. I like it. All right. So you guys are gonna. I'm gonna give you some time to read the vending machine problem.
What?
Yep, right there on page 173, right there. I'm switching screens. Alright, if you're not talking about vending machines, you're off task. Look at the vending machines. Alright, you're supposed to talk about this with your group. Something on task. Work with your group. You buy an item from the vending machine. What are two possible relations associated with the vending machine? It's kind of weird. Think about inputs and outputs of the machine. So literally find two possible relations.
Put a number in.
Yeah, I think I need
Sorry, no. You know how they restock it? Yeah.
You guys all sure you have the right one.
Yes.
Oh, I got it. As usual. Yes. Usually I have it. Alright, who can tell me a relation in this vending machine? What's matching up here? Yes, Gavin. Okay. No. Those, I see how you might say like these things are related because they're both for $1, but that's not an input and an output. Leilani. Becca.
Maybe the water and the juice because they're both liquids.
No.
Yes.
Tristan, are you on it? You guys with it? Are you guys on task right there? Check it in. I need a relation. No.
Would it be putting in money and then getting the food out?
Alright, but still not a specific relation. Tell me one relation. There's like 15 in here. Tell me one of them.
Putting in $1 and then buying a cake.
Is it a candy bar?
The granola bar.
Putting in 50 cents and then getting out over the
Wait, what are we?
That's our first relation. Our first relation. Input. 50 No.
Oh, face it over there. We need that back here. No, I need all of it.
I'm excited. Granola bar. Wow. Inputs and outputs. Gio, you get it? Gio, Brianna, Aubrey, you get it? Okay. Because you put the 50 cents in and you get out the granola bar. All right. Jacob, are you on task?
Yes.
I need Brianna to tell me a different relation in this vending machine. Sorry if it's Brianna. I always mess that up. Is it Brianna? Yes. Sorry, Brianna. The input is $1 and output is $0. All right. If you put in $1, you can get out cereal. Okay? A relationship or a relation is inputs and outputs. It's not two things that have a commonality, which is like the first 6 answers we came up with. We were pairing up things that they had in common. That is a type of like relationship, I guess, type of family. But a relation in this case is you put something in and you get something else out. Okay? So what the inputs are the money and the outputs are the food. Okay? All right. This is the important part right here. This is it. Does each input pair with exactly one output? No, it doesn't. You guys, actually, I got a really good solution. I've been thinking about this while I was teaching. No.
Are you turning it off?
Okay. Problem solved. No. Let's just focus. All right. So, guys, this is the most important part of this. This is why we do this whole activity. No, it doesn't. So I could put in $1, and I don't like. Listen, if I didn't have a code, if I didn't have software, I put $1 in. I don't know if I'm gonna get out the cereal or the water. That is not a functioning relationship. In a functioning relationship, you put something in, and you know exactly what you're gonna get out. Okay. So this does not have exactly one input with one output. Therefore, this is not a function. Laurie, try to focus. You can do it. Okay? Look at this sentence. The whole purpose of this was for this one sentence. This is not a function because if I put $1 in, I don't know what I'm going to get out. Okay? This relates to tables in math. If I'm going to build a machine, if I'm an engineer and I'm going to build a machine, if I put a piece of metal into my machine and it needs to make a car door, it always needs to make a car door. I can't wonder if I'm going to put a piece of metal in and it's going to give me a hammer instead of a car door, right? When we put something in, we have to know what we're getting out to be able to rely on it for science, okay? So we're going to look at numbers, and we're going to say if I put a number in, do I know exactly what number I'm going to get out? If I don't, then I cannot call it a function. Who's heard of relations and functions before? Raise your hand. Okay. Let's move on to the next page. We're on 174 right now. All right. In math, a function pairs one input with exactly one output. Underline that, just like I have. And answer this. How can I use a coordinate plane to represent a relation? What are the inputs and what are the outputs? Inputs are x values. Outputs are y values. Why is this hard to find? It's at the top of the next page. It's been up there. Alright,
Go back up. No. Page 181, 1 to 10.
Alright, you guys, so I just want to get you kind of focused and into perspective. You guys are going to have a quarter one benchmark in a few weeks. The whole entire state takes the same test and taking it in a few weeks. This question right here, letter D, is a guaranteed state test question. Alright? Is this set of points a function?
No.
Well, let's write the ordered pairs and see.
No.
You want to label it? Becca says let's label it. I like that idea. So I'm going to label this one. What's this red point here? Aubrey, what's this red point here? You got your X's and you got your Y's. She knows. She knows. You know, sometimes you get caught on and you get caught off guard. I kind of do that a few on purpose. It's really me. Alright, let's do this one. Don't say, what's this ordered pair? That's it. Alright, I'm going to color this one green. What's this green one? Meadow. Okay, keep going. Very good. I'll go light blue. Then I go to Elijah. What's this point? I think, yes, 7. Alright, good. I'm going to make this one black. What's this point? Jason. That's it. And then I'm going to make this last one orange. What's this one? Gina? Alright, so now, is this a function? Does this follow the input-output rule? Sharika, did I say input was X or Y? I know you wrote it. Okay, does each input X pair with one output Y? Yeah, that's what we're doing. Yes or no? Gio, is it a yes or a no?
Yes.
Let me ask you guys this. I'm going to ask everybody in this room, Sharika, focus. I'm going to take a survey. If I told you X is 3, what is Y? X is 3, what is Y? If X is 3, what is Y?
2. X is 3.
2 or 5.
Half of you guys would tell me 2. The other half of you guys would tell me 5. That's a fail. That is not a function. A real function, I could say, what is X? And you guys would all, if I told you X is 3, everybody would tell me the same answer. So if it's paired with 2 Y's, you're going to say, no, this is not a function.
Oh, so if there's 2 of the same.
That's not a function. So X3 paired with 2 different Y's, not a function. X is 3. If there's 2 different Y's, not a function. When X is 3, if there's 2 different Y's, it's not a function. So 3 goes with 2 and with 5? Not a function. Aubrey, were you able to get it? The whole purpose of this problem. So what is it? Why is this not a function? Yes. Alright, so if the same x value has 2 different y's, it's a no, not a function. You get it?
Hey,
No, you're just over there doing whatever you want.
I said it.
It's like Brandon, this is your fault.
Let's go over here.
It's just like
Alright, turn the page. Turn the page. Let's do this again. Alright. Be quiet now. Be quiet now. I'm trying to read you guys. Look, this problem can be presented in actually 5 different ways. Here's 4 presentations. By a list of ordered pairs, by a table, and this is called a mapping. What we're asking, it says, is it a relation? And that means, is there an x paired with more than one y? You guys want me to write it that way? Is there an x paired with more than one y value? Are you all right? Like, are we good? Can you do this problem? Like, I know you want to do it. Like, I don't know what's going on. You need to talk about something?
I thought if there was more than one, it's not a substitute. Wait, I thought one was not a function. If there was more than one, it's not a function, right?
no. Bro, look at her eye. Like, are you serious?
Yes, function.
My question. I'm not trying to like pick at you, but how? How did you pass it? I think you're gonna make mine. Huh? You do draw. But all online you do that.
Oh, it does say explain that, so I am going to explain.
Lord have mercy. No, yes, yes, yes. I mean, no. And I'm right. You got it right.
Which means you got all right. That's it.
I'm paying attention. But I'm more sarcastic.
You guys, so I was a little bit harsh with my whole 50% thing. Like in an honors class, there's a good chance more than half of it will pass, but it's just a little bit more. So be careful. Like, stay with it. All right, I got to do one more idea and I'm done. Yeah. Yeah, I got one more idea and then you're ready for that assignment. This is it. Can you guys find the vertical line test? Actually, raise your hand if you've heard of vertical line Same concept, right? Because if this was an ordered pair here, it would be 3, 6. And if this was, it would be 3, 4. Same idea. It can't happen. If you draw a line straight up and down and it hits more than once, it's a no. Just tell me if it's no for these and I'll move on. There we go. Alright, you guys can do your assignment.